Hi, our today's topic is random events. And before talking about random events themselves, let's speak about the main concept that is a basis of probability theory, a concept of a repeatable experiment with unpredictable outcomes. So, in our science, we suppose that everything we deal with is based on an experiment that can be repeated many times or can be observed many times. And each time this experiment ends with only one of several possible outcomes. And each time outcome is totally unpredictable. So we don't know the outcome before the experiment is done, before the experiment is repeated. I can give many different examples. The classical example is flipping of a coin. So you flip a coin and this experiment ends either with heads or with tails. And these are two possible experiments two possible outcomes of this experiment. Or you can roll a dice and this experiment has 6 possible outcomes, as the dice has 6 edges, 6 faces. Or you can, for example, ask your group mate, did you pass the exam? And he answers you either I did, or I did not, or I don't know yet. And these are 3 possible outcomes of this experiment. So the main 2 conditions are that we don't know the outcome before the experiment is done, and that experiment can be repeated and can be observed many times. Maybe the one who performs the experiment is not is not yourself, but still the experiment can be observed. Maybe someone else perform this experiment, but you can observe it many times. So let's discuss this concept with an example. So let's suppose that I'm a teacher and I have a group of 5 students and I want to ask some student a question, and I choose one to ask him a question at random. So this experiment obviously has 5 possible outcomes, as there are 5 students. So I can choose any of them. There are 5 possible outcomes. And this experiment can be repeated many times. I can ask as many questions as I want. Standard conventional notation for outcomes of the experiment are little letters omega. So omega 1, omega 2, omega 3, omega 4, omega 5 are outcomes of our experiment. Now, let's say that I know something about these students. For example, I know their names, I know their heights, I know their hair color, I know whether each student is Russian or foreign, and I know their if he or she is married or not. So after the experiment is done, after the student is chosen, I can answer questions like, is the chosen student Russian or foreign, single or married, does he have blonde or brunette or red hair, and so on. So, and there are a random event is a thing based on one of the questions of this kind. So after the student is chosen, I can say, for example, does his name start with letter A or not? Or is the chosen student married or not? And so on. So you see the examples of such questions, and these questions are actually what we call random events. So random event is an event based on our experiment that after the experiment is done, after the experiment is performed, random event either occurs or not. So, and how can we understand? Did our event of interest occur in this repetition of the experiment or not? We are to know which outcome took place this time. So how can we understand? Does the name of the chosen student starts with letter A or not? We should know, we must know who was chosen this time. So if our experiment ended with outcomes omega 1 or omega 2 or omega 5, this means that event A occurred this time. And if our experiment ended with omega 3 or omega 4, this means that event did not occur this time. So for each of these events, all possible outcomes of our experiment can be divided into favorable for this event and not favorable for this event, as follows. So you can just, it's a very simple task to choose favorable outcomes for each of the events you can see now. So you can see that any random event can be described either with a phrase like chosen student is Russian or chosen student is not married and so on, or as a set of outcomes that are favorable for this event. And so what is the mathematical definition of what a random event is? So the first term we use here is sample space. Sample space, we usually use capital letter omega to denote a sample space. It is a set of all possible outcomes of the experiment. And a random event is a subset of omega. So as you can see here, each of these events can be described as a set of little omegas. So all these sets are subsets of capital omega. Capital omega is a set of all little omegas. So mathematically, a random event is defined as a subset of a sample space of the experiment. And each random event is based on an experiment. So we cannot talk about random event of its own. So about random event without an experiment it is based on. And there are also two random events of a special kind that should be defined separately. They are a certain event. Certain event is an event that always occurs. What does it mean, always occurs? That means that every outcome is favorable for this event. So this event can be described as a set of all possible outcomes of the experiment, and so it is just equal to sample space. And so that is why we use the same letter for a certain event, capital omega. So this is an event that always occurs. This is an event such that all outcomes of the experiment are favorable for this event. And there is also an impossible event. This is an event that never occurs. And so this is just a set with no elements. And so we use this standard notation for such a set to denote an impossible event. So now, as we see that random events are actually sets, that means that all operations that are defined for sets are also valid for random events. So what are operations on sets? You already know. The first one is union of two sets. So the result of this operation is a set that includes all elements of both sets A and B. In probability theory, there are two standard notations. First one is more popular in English literature, and the second one is more common in Russian textbooks. So sometimes we use union sign for this operation, and sometimes we use plus sign, and we call this operation not union, but the sum of two events. So be ready to meet both notations. So sometimes they say union, sometimes they say sum, sometimes they say A union B, sometimes A plus B. So what is the physical meaning of this operation? This is actually, it can be described with the word or. So when we say A union B, that means that this is an event such that at least one of two occur. A or B or both. So the second operation is intersection. There are also two traditional names and traditional notations for this operation. Sometimes they say intersection of two random events, and sometimes they say product of two random events. So either A intersection B or A times B. The meaning is the same. And this operation can be described with the word and. So when we say A intersection B, this means A and B. So this is an event that such that both occurred, A and B, during the same repetition of our experiment. So the fourth operation is difference of two events. It is used not so very often, but still, you should know that there is such an operation. It can be described with the words but not. So A but not B. Difference of A and B means A but not B. So that means that event A occurred and event B did not. And there is also an event that is called either complement event or opposite event for A. And this event means that A did not occur. So, and there are two notations, either A bar or A with letter C in upper index. So that means C from complement event. And usually we say, while reading formulas, we say A bar or not A. So this operation is described with the word not. So now let us see how does it work with the example we have already discussed. So let here only two of the events we have discussed. So event A, name of the chosen student starts with the letter A, and event C, chosen student is under 180 centimeters tall. And let us see what is A union C. A union C means that the name of the chosen student starts with the letter A, or he or she is under 180 centimeters tall. And so at least one of two is to occur. So that is why we just unite these two sets. And the set of outcomes favorable for these two events is omega 1, omega 2, omega 4, omega 5. What is A intersection C here? This means that the name of the student starts with A and he or she is under 180 centimeters tall. So we intersect our two sets, and what is left is omega 2, omega 5. So for both A union C and A intersection C, we can describe these events just with our ordinary words, or we can describe them as sets of outcomes of our experiment. A different C, A but not C, means that his or her name starts with A, but he or she is not under 180 centimeters tall. And the only one favorable option for this event is omega 1. So omega 1 is the only one favorable outcome. And event A bar or not A or A complement means that the name of the chosen student does not start with the letter A, and you can see that John and Sergei's names do not start with A, so favorable outcomes are omega 3 and omega 4. So that is how these operations can be applied in practice. For the events we can describe based on the physical sense of the experiment that is done every time. So now it is time for a short review of operations on random events. Actually, you can prove these equalities yourself using these Euler-Venn diagrams. So you can draw these circles, unite them, intersect them, and you will see that all these equalities are true. So, but let me just read them. So, union of a certain event and any event is a certain event. So this means that at least one of two is to occur, and one of these two is a certain event, is an event that always occurs. So obviously this will occur every time. Intersection of omega and A is A. So this means that at least one of two is to occur, either event that occurs every time or an ordinary event. So this means that this is just means an occurrence of ordinary event A. Then union of an impossible event and A is A. So this means that at least one of two is to occur, but impossible event cannot occur. So this means occurrence of A. And intersection of the impossible event and A is an impossible event. So because this means that both must occur, an impossible one and an ordinary one. So, and this won't occur. Then union and intersection of a random event with itself is equal to itself. So A or A and A is just A. So A or B is the same as B or A, and A and B is the same as B and A. So this just proves equalities number 7 and number 8. Then number 9, number 10, and number 11. Let this be a task for you, just to prove these events, to prove these equalities using diagrams. 12. A or not A is equal to omega. Yes, because at least one of two must occur every time, A or not A. So every time A either occur or does not occur. So double not means just absence of any not here. So not A is just simply A. Equality number 13. So sometimes these properties of operations on random events can simplify your solutions of problems and so on.